Our lesson for today, we are going to look at chemistry 1501, Lewis structure of SO3. Let us start. Before we can draw a Lewis structure of SO3, we need to find the valence electron of SO3. Now, to find the valence electron of SO3, we are going to look at the sum of the two valence electrons that makes this sulfur trioxide. In this case, we are going to look at one atom of sulfur plus 3 atoms of oxygen. Now we know that sulfur is in group number 6, so it has 6 valence electrons, and then we know that oxygen is also in group number 6, so it has 6 valence electrons. Now you can see that 6 multiplied by 1 is 6 plus 3 multiplied by 6 it's 18. Then 18 plus 6 we have 24 valence electrons. So we are going to fill in 24 electrons when we are drawing the Lewis dot diagram. Now we are going to put sulfur in the middle, then we are going to put our oxygens surrounding sulfur. Now remember, we need 24 electrons, so we have 1, 2, 3, 4, 5, 6, 7, 8. Our oxygen has reached its octet state, so we have 8 electrons. We continue 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we are going to stop at 24 since we said our valence electrons is 24. Now in this case, we can see that each and every oxygen has reached its octet state. So it is actually satisfied, except for sulfur. Sulfur did not reach its octet state. You can see that it only has 6 valence electrons. We should do something about that. So what we can do, we can rearrange our set of electrons. Now in this case, we can take this lone pair and making it bond with the other electrons. So if we perform that operation, we are going to have something like this. We still have our 8 electrons here. Then we are going to have 1, 2, 3, 4. Actually, let us continue from our first electrons. So it's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now looking at this, we can now count how many valence electrons. Sulfur has 1, 2, 3, 4, 5, 6, 7, 8. You can see it has reached the octet state. Looking at this oxygen, we have 1, 2, 3, 4, 5, 6, 7, 8. It's also satisfied, and the other 2 oxygens are also satisfied. Now, in order for us to actually verify that this is the best structure or value structure for SO3, we need to calculate the formal charge. Now, the reason why we need to verify that this is the best structure is that sulfur can actually hold more than 8 electrons. So, in that case, it means that there is, or we can actually draw a Lewis dot diagram of this compound. So we need to calculate the formal charge. There is a lesson video on how to calculate formal charge. Do watch that video. It will assist you to actually know how we came about this equation, how to use it. Now in this case, let's calculate the formal charge of our first oxygen. You can say this oxygen. The formal charge of this oxygen, we are going to look at the valence electron. of oxygen minus the number of bonds minus the number of dots. Now the valence electron for oxygen we have 6 because zinc group number 6. How many bonds? We have only one bond. Minus how many dots do we have? We have 1, 2, 3, 4, 5, 6. So you can see that the formal charge here is -1. So for this oxygen we have formal charge of -1. Since this oxygen is identical to this one, it's also going to have -1 as the formal charge. Let us calculate the formal charge of this oxygen. So the valence electron is 6 because we are still dealing with oxygen, minus the number of bonds. We have 2 bonds, it's 1, 2, minus the number of dots. We have 4 of them. So you can see that 6 minus 2 minus 4, it's actually 0. So for this oxygen we have 0 as the formal charge. Let us calculate the formal charge of sulfur. Valence electron, sulfur is in group number 6, so it has 6 valence electrons. The number of bonds, it has 1, 2, 3, 4. So we have 4 minus the number of dots. We actually have 0. So 6 minus 4 is 2. So you can see that the formal charge of sulfur in this case is 2. Now you should know that if there is another Lewis dot diagram that we can actually draw for this compound SO3, and then when we calculate the formal charges, we find numbers which are actually closer to 0 compared to 2, 0 and -1. It means that Lewis dot diagram will be the best or the correct one for sulfur. Now we can rearrange the Lewis dot diagram again. We can actually take this lone pairs or pair of electrons and bond them here, and also for this one we take this pair of electrons, we bond them here. That will result into something like this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we actually have double bonds. We can draw this like this. So let us go ahead and calculate the formal charge quickly. Let us start with oxygen, this oxygen, but we can see all these oxygens are identical, so we can only perform the formal charge only once, and then it will be applicable to all of them, minus the number of bonds minus the number of dots. So in this case, oxygen has 6 valence electrons, minus the number of bonds, it has 1, 2, minus the number of dots, it has 4. So you can see that the formal charge in this case will be 0. So the formal charge for this oxygen is 0, for this one also 0, 0. And then the formal charge for sulfur, we have valence electrons is 6, minus the number of bonds, we have 1, 2, 3, 4, 5, 6, minus we don't have any dots, so you can see that sulfur has 0 formal charge. Now in this case we need to compare the two. The Lewis dot diagram that has the formal charges that are actually close to 0 is the one which is the best or correct. So you can see that this one has 2, positive 2, 0 and negative 1, and then this one contains only zeros. So it means that the correct Lewis dot diagram for SO3 it's actually this one. That's it for this lesson video. This is Wahula SJ. Thank you very much.